Okay, in this last video on limits, calculus conundrums, limits, let me remind you that you shouldn't be trying to apply L'Hopital's rule unless you have studied how to find derivatives. So again, this rule generally comes after the chapter on differentiation or finding derivatives. So basically, the second part just tells us that we can apply the same rule if we get the form infinity over infinity. Okay, so if we get the form infinity over infinity, we can apply L'Hopital's rule in the same manner as we applied it in the last video. So let's take a look at the limit of natural log of x over x as x approaches infinity. Okay, well, you're familiar with the natural log function, and you should know that it's an increasing function. So as x goes to infinity, the natural log of x will go to infinity. So the numerator will go to infinity as x goes to infinity. And obviously as x goes to infinity, x will go to infinity. So this has the form of infinity over infinity as x goes to infinity. So therefore I can apply the rule. So remember how to apply the rule. I didn't show the intermediate step here. So how do you apply the rule? You take the derivative of the numerator, which is 1 over x, and then you take the derivative of the denominator, which is 1, and so you get 1 over x divided by 1, which is just 1 over x. And now if I take the limit of 1 over x as x goes to infinity, well, we know that 1 over x goes to 0 as x goes to infinity, so therefore the limit there is 0. And I've only got one other one. This video is going to be relatively short. Here I have the limit of x times natural log of x as x approaches 0 from the right. Now the reason it says 0 from the right is because you can't approach 0 from the left for the natural log function. So it has to be 0 from the right. Okay, so if you let x approach 0, you obviously get 0. And if you let x approach 0 for the natural log function, remember, the closer you get to 0, the farther down it goes. So this would actually be it'd be negative infinity, but it's okay. I wrote just infinity. But as long as it's a product of 0 and one of the infinities, then it's an indeterminate form. So now what I can do here, I did something similar in the previous video. What I can do now is I can move this x to the denominator, and then that way I can write that as 1 over x. And now if I let x go to 0, then the natural log of x still goes to infinity, and then 1 over 0 goes to infinity. And so I have the form infinity over infinity, so I can apply L'Hopital's rule now. So all I have to do to apply L'Hopital's rule is take the derivative of natural log of x, and that's going to be 1 over x, and then take the derivative of the denominator, and that's going to be minus 1 over x squared. And now if you just invert this and multiply it, you'll get 1 over x times minus x squared, which is going to give me minus x. You can do that on scratch paper if you want to. So now I have the function. Now all I have to do is take the limit of negative x as x goes to 0, and that's simply going to be 0. And so this completes the calculus conundrums section for limits. And there's another section I've already got published for derivatives, and I'm also going to do a section for integrals when I get the chance.